right, multiplying by a complex number, I. Okay, this is your real axis, this is your imaginary axis. So when I multiply by I, that's a 90-degree counterclockwise rotation. I squared, 180, I cubed, 270, and I to the fourth, 360. All right, so this is a rotation of 90 degrees. Okay, number 2, which of the following transformations is the result of multiplying or dividing by I? So if this is multiplying by I, dividing by I goes the other direction. Okay, so if I divide by I, I'm going to go this direction. So that would be I squared, I cubed, and I to the fourth. But it goes clockwise. All right, so dividing by I would be a 90-degree clockwise rotation. It's opposite than multiplying by I, which is 90 degrees counterclockwise. Okay, what's the geometric effect of multiplying I squared times Z? Well, I squared is going to be a 180-degree turn, and it doesn't matter if it's clockwise or counterclockwise because it's the same place. Okay, what's the geometric effect of Z with a bar? So that's the conjugate. So if we had a point, let's say this point was 2I, its conjugate is going to be 2 negative I. So that's the same as flipping it over the real axis or the x-axis. All right, what is I to the 52nd? So you have I to the 0, that's 1, or 0, I'm sorry, 1. Then you have I to the first, which is I to the second, negative 1, I to the third, negative I, and I to the fourth is 1. So I'm going to see how many I to the fourths go into 52. All right, so if I take 52 and I divide it by 4, all right, okay, it goes in 13 times. So this I to the 52nd is really I to the fourth to the 13th power. Okay, that would be the same as I to the 52nd. I to the fourth is 1. 1 to the 13th is 1. Okay, find the modulus of Z. So that's a squared plus b squared. So that's 1 squared plus 3 squared. 1 plus 9 is the square root of 10. Okay, what's the argument? All right, so our argument is arctan b over a. So this is going to be the arctan of 3 root 3 over negative 3. And that's going to simplify to the arctan of negative root 3. And then we'll go to our unit circle and find that. Now when we look at this, we know that this right here is going to be in the second quadrant. So we're going to find the arctan of negative root 3 in the second quadrant. Okay, so second quadrant, I'm looking for a tangent that is negative root square root of 3, so that is 120 degrees or 2 root 3. Okay, what is the conjugate of 3 minus 4i? Well, that's simply just 3 plus 4i. Okay, which point shows the conjugate of z4? Well, when you do a conjugate, it's going to flip it over the real axis. So that's going to be z1. Okay, what do you do to divide complex numbers? You multiply by the conjugate of the denominator. So I'm going to multiply the top and the bottom by 3 minus root 2. Okay, use your unit circle to find the argument. All right, so this is a positive, negative, so that's going to be in quadrant 4. Positive, positive, negative, positive, both negative, positive, negative. So this is in Q4. So I'm going to go to my unit circle and find those cosine and sine values. Okay, so this is the cosine. This is my sine. And in quadrant 4, that would be right here. So that's 11 pi over 6, or 330, or negative 30. Okay, so in this case, 11 pi over 6. Okay, what's the value of this division? So previously we saw you had to take these two. You got to multiply the bottom by the conjugate and the top by the conjugate of the denominator. So now we've got to do these two multiplications. Okay, so I've set them up. Here we go. 1 times negative 2i, negative 2i. 2i times 1, 2i. 2i times negative 2i, negative 4i squared. All right. Now, let's see. These are going to cancel. So I've got 1 minus, or plus, negative 4i squared. I squared is negative 1. Okay, so this just becomes 1 plus 4, so the denominator is going to be 5. Okay, and now my numerator, we got 2, negative 4i, 9i, negative 18i squared. All right, so let's see, we've got 2 plus negative 18i squared plus 9i plus negative 4i. All right, so that's going to be 2 plus, we got negative 18, I squared's negative 1. So now I got 2 plus 18, and now I just combine my like terms. So that's going to be 20 plus 5i, and that's my numerator. Okay, and then I can split these up into two fractions and reduce them to lowest terms. And that gives me 4 plus I. Okay, now they're not reduced on this one, so there's my answer. Or that could be my answer. Okay. All right, find the midpoint. So to find the midpoint, you add the 2 and then divide by 2. All right, so I've got 3 plus negative 1, that's 2. 4 plus 6, that's 10. Divide by 2. Got 2 over 2 plus 10i over 2, which is 1 plus 5i. Okay, find the the distance. So to do the distance, you subtract the 2 and you do the modulus. Okay, so I'm going to go 4 minus negative 2. 4 minus negative 2. Okay, that's going to be 6. And then I'm going to do negative 3i minus negative 4i. All right, negative 3 plus 4, and that would be I. Okay, so that's what this is. And all I did there was I did z minus w. Okay, now I'm going to do the modulus of that, which is going to be 6 squared plus 1 squared, which is 36 plus 1, which is root 37. Okay, express the point in polar form. All right, so what we got to do is go to your unit circle and get the values of cosine and sine of pi over 3. Okay, so at pi over 3, my cosine is a half. So this gets replaced with a half plus I, and the sine there is root 3 over 2. Okay, then you just distribute. And simplify. All right, what's the effect of adding 5? So when we add a real number, if you add or you subtract a real number, okay, your graph is going to move right and left. So this is going to move 5 places to the right. That's going to be 5 right. All right, so it's currently, looks like this is 3, 3. So it's 3 plus 3i. So when I add 5 to it, it's going to become 8 plus 3i. So it's going to become 8 plus 3i, and it's going to move to the right. Okay, which of the following is a multiplication of z1 by I? Okay, so here's z1. Okay, so when I multiply by I, that's 90 degrees counterclockwise. So it's going to move to z6. Okay, now what happens when you multiply by 2? Well, that's going to dilate by 2. Okay, so z1 is here, so the distance that it's from 0 is going to double, so it's going to end up at z5. Okay, what's the effect of subtracting 3i? Well, when you add or subtract an imaginary number, it moves your point up and down. So our point is going to move 3 places down. Okay, which of the following transformation is the result of multiplying by I? Okay, I is a 90-degree counterclockwise rotation. Okay, which of the following is the result of multiplying by 1 plus I? All right, well, 1 plus I is going to, let's see, its modulus, it's going to dilate by its modulus. So its modulus is going to be 1 squared plus 1 squared. So it's going to dilate by root 2. And then its angle, its rotation or argument, is the arctan of B over A, arctan. Okay, B is 1 and A is 1. Arctan 1. Okay, this is in quadrant 1. So I go to my unit circle and I find where the tangent is 1 in quadrant 1. So there it is. That would be 45 degrees counterclockwise. So right here. Okay, what's the geometric effect of adding? So now you're adding, you're not multiplying here. So when I add a real number, that's going to be right and left. So this thing's going to go 3 right. Okay, when I add or subtract an imaginary, it goes up or down. Since I'm subtracting 3i, it's going to go 3 down. So you're not multiplying by this, you're adding it. So that's why it just slides. It doesn't rotate and dilate. So this thing's going to go 3 right and 3 down. Okay, geometric effect of multiplying. Okay, so if I multiply by 2i, the 2 is going to dilate it by a factor of 2, and the I is going to rotate it 90 degrees counterclockwise. Okay, so let's see. It's going to rotate, dilate by 2, and it's going to rotate 90. All right. What would you multiply a complex number by so it rotates 90 degrees clockwise and dilates by a factor of 3? All right. So here's the key here. This is clockwise. So if I had a point and it rotated 90 degrees clockwise, it's going to go this direction. And it's going to dilate by a factor of 3. Okay. All right. So this would dilate it. Choice A would dilate it, but it would go 90 counterclockwise. Okay. This, it would move 3 right, 1 up. Okay, D would just dilate it. So negative 3. All right, so the 3 is going to dilate it. Okay, the I is going to rotate it 90 counterclockwise, but then the negative is going to rotate it 180. So what's going to happen is this point is going to go up here. All right, that's my 90 counterclockwise, and then it's going to go 180 down to here. All right, so it's going to be B. Okay, what's the shortcut for multiplying complex numbers? All right, so our shortcut is, if you're multiplying two complex numbers, okay, the modulus of z1 times z2 is equal to the modulus, the individual moduluses multiplied, and the argument of z1 times z2 is going to be the sum of the arguments. So the sum of argument of z1 plus the argument of z2. All right, so I'm going to add, I'm going to multiply the moduluses, okay, right here, and I'm going to add the arguments. So on this next example, we want to multiply these two. So I'm going to multiply the moduli. So I'm going to multiply the modulus of each one. Okay, so that's going to be 9 times 3, 27. And then I'm going to add the arguments. Which is 50 plus 110. So that's 160. So I'm looking for 27, 160 right here. Okay, all right. What is negative 8 root 3 minus 8i in polar form? Okay, so in polar form, I've got to figure out what the modulus is. So I've got negative 8 root 3 squared plus negative 8 squared. All right, now when I square negative 8 root 3, that's going to be negative 8 squared times root 3 squared, which is 64 times 3. All right, so that's going to be 3, 12, carry the 1, 18, 192. And then I'm going to add negative 8 squared, which is 64. And then I add those two up. Okay, so my modulus is 16. So it can either be, in this case, choice B or choice C. All right, then I've got to do my angle. So my angle for this one is going to be the arctan of B, which is negative 8 over A, which is negative root 3. So that's arctan. Okay, those cancel, so I have 1 over root 3. All right, this is a negative and a negative. So this is in quadrant 3. So I'm going to go to quadrant 3 and look for that tangent. So 1 over root 3 is the same as root 3 over 3. So that's 210 or 7 pi over 6. So my answer is B. Okay, I want to rotate the point. Okay, it says rotate the point 120 degrees about the origin. Okay, so we're going to automatically assume that this is 120 degrees counterclockwise. So we're going to go 120, which is right to there. And that would be, let's see, my sine and my cosines are negative 1/2 and root 3 over 2. So negative 1/2 and positive root 3 over 2. And there's my solution. And that's it.